10, what we're going to do, it wants us to solve the following expression: x cubed minus 1.1 x squared plus, oh no, not plus, minus 65.4 x plus 229.5 equals 0. Now normally the way that you would solve this thing, sometimes we try to factor things. That's how we teach you guys. Really, we just use that. But in the real world, you'll never get an equation where x cubed minus 2 x squared plus 3. It's never integers. It's always like messy. It's always decimals. And you can't factor this using the box method. You could factor it using some other methods, but to solve this, we're going to have to use a graphing calculator. Okay, so let's pull up the graphing calculator and see how we would do that. How do you guys suggest that we solve this? How do I solve that using my graphing calculator? Can't do a quadratic equation or formula because it's not a quadratic. Can't factor out an x to make it a quadratic. To do synthetic division on it would be too complicated because of all the decimals. So what do? How do we find the solutions? Well, we're looking for when it's equal to 0. So what I'm going to do is I'm going to graph it. And so I'm going to say x cubed minus 1.1. Now, how many possible solutions would there be for this if we have x cubed? There may be 3 at most. Okay, 65.4. You guys double checking to make sure I'm entering in the correct stuff? It's always embarrassing at the end when I do the work and we have an answer, but it's not the one in the back of the book. So we graph it. Boom, boom, boom. Uh-oh, looks silly. Now in the textbook, now we think there's 3. How many do you guys see?
2.
Yeah, it's 2. It's one solution, multiplicity 2, right? So where's that third one at?
Up.
I don't know. We gotta zoom out a little bit maybe. So let's do a standard fit and see if we can make this thing fit inside the thing. All right, there we go. Does that make sense? All right. So what do I do next? Find the x-intercept, right? When y equals 0 is the x-intercept. So what I'm going to do is hit second trace, go to 0. That's what we're trying to find, is the zeros. And it says left bounds. So I don't know where we are on the graph, but it looks pretty far over here. So I think it's about 9. So I'm going to keep going. We should see it start to come into the screen soon. Oh man, that's crazy. Do you guys see it at all? I don't see it at all on the graph. So how do we figure where it is? This is a hard one.
Zoom.
Zoom where? How about this? How about we look at the table first? So what am I looking at the table for? I'm looking to see where it equals 0. See, we're used to pulling up the grapher and then being able to nicely zoom in and out. The problem is that the way this graph shows on the screen, it won't even, when I try to get to the solution, it won't show. Well, we knew that 5 was a possible solution, and this kind of confirms it. But let's go the other direction, because there was something in the negative direction. Now see how my numbers are decreasing? So I'm getting closer. Oh, there it is, 9 and 10. So we go from a value, look at this, when x equals negative 8, y equals 170. When we get to negative 10, y equals negative 226. When I go to graph this, if I hit trace, notice that when I scroll through, I don't get close enough to 9, or negative 9, I should say. The cursor doesn't even show up on the screen. Now we could zoom out a little bit. That was one suggestion. So if I zoom out a little bit, whoops, if I zoom out a little bit, maybe that'll fix it. Let's see. Zoomed out. Well, at least I can see it now. So let's hit trace and see what it does when I trace in. Well, at least I know it's closer to 9, but it still doesn't get in close enough. So how would you solve that on your calculator? See, what we're doing today is we're looking at the limitations of our calculator and figuring out how to work around it. The calculator will get us close to the answer, but truthfully, we got to do some work ourselves. So one thing that you could do is, how do I get in close right here if I didn't know the answer was -9? Well, what I'd have to do is I'd have to hit second table set. Notice that I'm counting by what? Ones. So I'd have to come in here and change this to 0.1. Now when I graph, if I hit trace, I get a little closer. Well, actually, no, I don't. So I'd either have to manually enter it in. Like, how could I do that? I could manually enter it in. I could hit trace. We see here by looking at it, it's between negative, see how that's -8.9, and then if I go a little bit to the left, it takes me all the way to 9.7, -9.7. I could enter in -8.99 and see where that gets me. Well, that gets me a little closer. I could enter in -9.1 and that gets me a little closer. Do you see how I did that? Now let's try that with the second calc menu. If I hit second calc and then I go to 0, I don't want that far away, so I'm going to hit enter in -8.9. Now for my right bound, I'm going to hit -9.1. And seeing that it's a little bit to the left and a little bit right, I'm going to hit -9. Now Mr. Adams actually made a mistake. I should have entered them the other way around, shouldn't I have? But let's see what it does. Yeah. I put the left bound in for the right bound and the right bound in for the left. Could you imagine trying to figure this out while taking the ECT? You get frustrated with this, right? That's why we're practicing it now in class. So when I change that though, look at this. I could really, when I change that table set, what it does is it changes how I calculate the table. So I can almost find the answer through the table as opposed to graphically by changing that table set. I could see that it's close to 9. This may be a rounded answer. So what I could do is start at -8.9. In other words, I could come in here and say, and we did this once before, I could say -8.95 and change this to 0.01. And then when I hit the table, I can just kind of scroll up and see, you know, where my answer may live. Oh, I entered it in wrong. It's it's negative, not 8 point, I put the decimal in the wrong spot. 8.95. Now when I get here, I could see that if I go a little bit closer this way, see how it's getting smaller? See how the X values are counting? See how the Y values are getting smaller? And then I can hone in on it. See how I did that? So that's what you would need to do.